Let's solve a few problems involving mechanical energy. This first one being kinetic energy. So here's our problem statement. A car weighing 13 kilonewtons and traveling at 80 kilometers per hour comes to a complete stop. How much energy is dissipated by the braking system of the car? And we would like that energy value in kilojoules. So here's the data we were given. We're given the weight of the car, not the mass. That's the weight. We're given the acceleration of gravity and the velocity that's dissipated. So the initial velocity is 80 kilometers per hour. The final velocity is 0. So we'll recognize that the braking system dissipates all of the kinetic energy that the car had to bring it to a complete stop. So we can say that the kinetic energy is the energy dissipated by the brakes, and that's 1/2 times the mass times the change in velocity squared. I've just written it here as the velocity squared. Now we were given the car's weight, not the car's mass, so we're going to have to find the mass. Well, weight is just mass times the acceleration of gravity, and so if we can rearrange that, we have mass as weight divided by the acceleration of gravity. So we have a weight of 13 kilonewtons. The acceleration of gravity is 9.807 meters per second squared. And all of these other terms are just unit conversion terms that we have. There's 1,000 newtons and a kilonewton, and a newton is 1 kilogram meter per second squared. So we get the mass of the car is 1326 kilograms. Now we can solve for kinetic energy. Kinetic energy is 1/2 the mass that we just calculated times 80 kilometers per hour, that whole quantity squared. So we're squaring the 80 and we're squaring the units, all right? And the remaining terms here are all unit conversions. So we're converting kilometers to meters. There's 1,000 meters and a kilometer. And because kilometers here is squared, I have to square this conversion term because I have square kilometers. Same thing here, 1 hour is 3,600 seconds, but I have square hours, or hours squared. So I have to square this conversion term so that I have also square hours. Then a newton is a kilogram meter per second squared, and 1,000 newton meters are equivalent to a kilojoule. Now all of these will cancel, and I'll be left with an energy term of 327 kilojoules.